have a random variable x has a binomial distribution. Now, we had a whole chart of things. What was the expected value of a binomial? You flip a coin 40 times, how many heads would you expect? 20, because to find the expected value, what do you multiply together? N times P. Yeah, that's it. And then for the variance, it's N times P times Q. And I like to just go NPQ, but it's 1 minus P. So we had some rules. We had the expected value of x plus y. That was the expected value of x plus the expected value of y. We also had the expected value of a linear transformation, Cx plus d. Remember that that was c times e of x plus d. Sound familiar? Right? So we're going to use this stuff to figure out what they're asking for here. And all that they're saying is that if you have x over n for a binomial distribution, it's going to be able to be represented as p. Is an unbiased estimator just as saying is equal to p? It's kind of lame. It looks complicated, but all they're trying to do is to say that this equals p. So expected value of x over n. Now, what was the expected value of cx? What was that equal to? Forget about the d. What's the expected value of cx? C times e of x. So this is like 1 over n is kind of like our c. So we're going to pull that 1 over n out, and you're going to get expected value of x. How's that look? And for binomial, Blake, what's the expected value? NP. So we have 1 over n times NP, and what do you get? You get P. And that's what we were looking for. We were trying to see that it was equal to P. Next, we're going to do this one. We're going to take the expected value of this one, x squared over n squared, if you distribute that square in, and we're going to show that it is not equal to p squared. So we're going to prove that it does not equal p squared. So see what you can do with this. See how far you can get. Remember, these are easy. Remember what the variance is equal to? Yes, there's e of x squared. Whoop, try again. E of x squared minus e of x quantity squared. Yep. So what's e of x squared going to be equal to? Yeah. So we're going to rewrite this. E of x squared over n squared. That's going to be 1 over n squared times e of x squared. But this is equal to, the variance of x plus e of x quantity squared. Oh, that's rough. But not really, because for a binomial, what's the variance of x equal to? NPQ. And what's the expected value equal to? NP. All right, so you're going to get 1 over n squared NPQ plus n squared p squared. Now, it's kind of frustrating because nothing great is going to factor out. You're going to take out an np over n squared, and what will be left? q, right? So that's 1 minus p, and then there'll be plus np. Is there any way that this is going to be equal to p squared? I don't think so. So it's np over n squared, 1 minus p plus np. It can't simplify. This is not equal to p squared. So we're done. Was I right? This isn't too bad, is it? No. Try this one. Try this last one. The last one says, find the expected value of x squared minus x over n times n minus 1. So before you get too Twitter-pated, what can we pull out in front? One over n times n minus 1, and then you're going to get e of x squared minus e of x. We had a substitution here we're going to have to make. What substitution is it? What substitution do we make? This is can't do anything with this. What can we replace e of x squared with? Variance of x plus e of x quantity squared. Yeah. Minus e of x. Anybody forget that part? Marie, what should I do next? Yeah. NPQ, NP, NP. So, got a little bit of algebra to do. I'm going to pull out in front, looks like an NP. Okay. And this is going to be Q plus NP minus 1. And Q, of course, is what? Is that a good thing? 1 minus P, is that a good thing? What cancels out in these parentheses? The ones, yep. So now what you're going to have, and I can cancel out one of these n's. So I'm going to get P over n minus 1, and then I'm going to get negative P plus NP. What can I factor out of here? Another P. So that's going to be P times P, leaving negative 1 plus n. And in the denominator is what? Yeah. N minus 1, or negative 1 plus n. So, isn't that a gratifying one? That's pretty cool. I like that. And that's typical of a further math question. Is it's got some surprises to it. It leads somewhere interesting, and someone put a lot of thought into it. But any questions on that? Turn to your neighbor and explain that one from beginning to end. A, B, and C. Go. Just a quick reminder, number 7 you don't have to worry about. So if you haven't crossed it out, cross out number 7. 8, I wanted to do with you. 6, I want you to do on your own and check the answers for. And then were there any others of these that you wanted to look at? Binomials or Poisson? Love the binomial ones. They're kind of similar to what we did this year. Let's go to number 4 real quick, if you don't mind. It says, let X be the number of emergency calls made to the police per hour. The calls arrive at random, and an average number of calls per hour is constant. Explain why X is a Poisson variable. Well, do you have a lambda, a rate? What would it be? Calls per what? Hour. So you have a rate, and then you can have a call, or you can have a not a call. You can have a pass or fail. That's good. And then could you have unlimited? It's like with your phone bill. Isn't it nice to have that unlimited minutes? Same thing with calls. Could there be an unlimited number of calls? Well, sort of. You know, you could have as many as could buzz in an hour, but it sure could be a lot of calls. So those 3 criteria, that it's a success or fail, unlimited, and a rate, then you would say, therefore, use Poisson or Poisson. Now B, love B, because do you remember what the expected value of a Poisson distribution was? Yeah, they both were mu. And mu is just the lambda times the time or the length or whatever you're using for a variable. So once you know mu, you know the expected value and you know the variance, which is pretty crazy. Suppose we know that 2 variance equals e of x squared minus 15. We should be able to find the expected value because what's the variance? Mu. And what's the expected value? Mu. So could we put this on one side and solve for mu? I love this. What does that negative 15 factor into? Wow, negative 5 and 3. So we'll have 2 cases. We'll either have mu equal to 5 or mu equal to negative 5. Well, or negative 3. Wait a minute. This will be plus 3. Negative 5 plus 3. So mu is going to be equal to negative 3. Which of those make no sense? Negative 3 calls? No. So I would say the mean is 5. Would you have ever thought that was 5? Pretty cool. And then when you find this p of x less than or equal to 3, all that you're doing there is you're taking the Poisson x less than or equal to 3. That's the Poisson for 0, for 1, for 2, and for 3. Now what we would do if we had a calculator, we'd just say Poisson CDF mu, which is 5, and we would go up to and including what? 3. You just do that in your calculator, which is admirable. It's wimpy, but it's admirable. But, you know, you could do it with a little bit of dignity, but not much. But you could, if you wanted to, you could go mu to the x e to the negative mu over x factorial. You could actually use that formula, and we know mu is 5, so we could go 5 to the 0 times e to the negative 5 over 0 factorial. That's this one. And then we can do the 1, 5 to the 1, e to the negative 5, all over 1 factorial. You can do 5 squared over 2 factorial. And you can do 5 cubed over 3 factorial. And if you wanted to, you could factor out an e to the negative 5, and you're just going to get 1 plus 5 plus 25 over 2 plus 125 over 6. And then that would be your probability. That's more dignified. That's going to get you dates with math people. Not the goal. Okay. That's all right. Let's look at 5 real quick. Got some pictures, my high school pictures up. In a mining process, the workers regularly use chains of length 50. Somebody second hour said, "That's not you, Dr. Sauer. That's too small. My guy's too small." Yeah, probably. Except in the 70s, my hair was like this. If you looked at me for, no, it wasn't an afro. It was just lots of hair. And then, if you looked at me from the side, you couldn't see me. I was so skinny, like 130 pounds. In a mining process, the workers use chains of length 50. It's known that chains from a particular manufacturer have faults. 1 per kilometer. When you see that 1 per kilometer, 1,000 meters, what are we thinking? What's that equal to? Lambda, right? That's your lambda. So what's mu going to be for 50 meters? (50) times 1 over 1,000. Remember, lambda times t is equal to mu. So, what's that? Same units? Yeah, these are meters, so this is going to be 50 meters per meters. That's why I use 1,000. Great point. So this is going to be 1 out of 20. If you simplify that down. Faults per meter. Faults per meter. So what's the probability that no faults in a 50-meter length chain? So the probability that x equals 0, and you just go mu to the x, e to the negative mu over x factorial. So that's just going to be 1 out of 20 to the 0, e to the negative 1 out of 20 all over 0 factorial. And that's just going to be e to the negative 1 over 20. And you can certainly use your calculator. At most 2 faults. So if we're saying probability that x is less than or equal to 2, we're talking about probability of 0, probability of 1, and probability of 2. You can do that with your formula, or you can do that with a calculator. Are you okay with that? You don't need to do that. Good. And then the whole purpose of doing this is transitioning you to confidence intervals, which we're getting to next. A chain is considered safe if there is at least a 99.5% chance there'll be no more than 1 fault in 50 meters of chain. Should the chains from this manufacturer be considered safe? Okay, so they're saying here probability of 0, of x equals 0, one fault in 50 will be no more than 1 fault in 50. So wait a minute here. So wait a minute. This should be mu is going to be that 50 times 1 over 1,000 again, which is 1 over 20. And we're expecting x to be no more than 1, so it should be less than or equal to 1, right? So then you would calculate probability of 0 plus probability of 1. Let's do that right now. Get your calculators out. What is Poisson CDF 1 over 20 again, comma, up to and including 1 will go 1 there. What is that probability? And I need 4 decimals, please. 0.9988. Okay. So at least is this probability here, is that greater than 0.995? Yes. Therefore, chain is safe.